All right, so for those of you who don't know us, we are the co-founders of Astronomy on Tap Austin. I am MC Heisey, also known as Dr. Rachael Livermore.
And I am MC SuperDuperNova, also known as Dr. Jeff Silverman. We're both researchers at UT Austin. All right, so warp speed. So this is a clip from the second trailer that came out, and we also saw this in the movie, of the Enterprise doing warp speed. And I think this is the first time that we see from the outside, from the side in the Star Trek universe of warp speed. And, you know, it's said the Enterprise folds space-time around it to create a warp bubble, and that's how they get warp speed faster than light. And so that's what they're depicting here. And we sort of think, like, if we were going to go faster than light, if we were going to do this kind of warp drive, that's what we would do. Einstein's general theory of relativity says that mass or energy can warp space-time, and so that's kind of what's going on here. You see the sort of wake behind it, which I think is a really cool visualization. The stars and some of the background images get kind of warped as space-time is getting warped, and this effect is gravitational lensing, what MC Heisey works on for her career. So I thought that was pretty cool. There is the image of actual galaxies doing this exact lensing. This is an image from Hubble that came out just about a week ago. The big fuzzball in the middle is a galaxy that's only about 4 billion light years away. And then these kind of archy, blue, curvy, stretched out things are background galaxies that are getting lensed, warped because of space-time being warped by the gravity of the nearer galaxy. So that's pretty cool. And of course, other movies have shown similar effects. This is the Gargantua black hole from Interstellar, and similar warping of space-time because of Einstein's general theory of relativity.
All right, and that image of the cluster is actually what I'm working on at this moment, because we just got the data from the Hubble Space Telescope a couple of weeks ago, and it's pretty shiny. It's very cool. So you may have noticed right back at the beginning of the movie, we heard that the Enterprise has been in space on its 5-year mission for 966 days. 966 is, of course, a reference to 1966, which is when the original series of Star Trek first aired. But the thing that I picked up on here is days. We all know what a day means. It's the period of rotation of the Earth. For a united federation of planets, it's a really weird way to measure time. You can imagine if you're one of the other alien species that's part of Starfleet, that would get really weird and annoying. Of course, we all know that Starfleet is actually very Earth-centric for all their talk of unity or whatever.
So nebulae in the Star Trek universe are these big, scary plot devices that show up in original series episodes, Next Gen episodes, Wrath of Khan, Star Trek V, the first reboot, and this one. And they're really not that scary. They're just used as plot devices. In this movie, we see these giant boulder things crashing into each other, making it hard for the Enterprise to get through. If it was anything like our own asteroid belt or Kuiper belt, we would have boulders that big, certainly, but they would be 1,000,000 kilometers away from each other. So they're much, much more spread out than anything you would see in this movie. Star Wars universe has the same problem of asteroids and rocks being too close to each other. The other thing that we see in Star Trek Beyond and Wrath of Khan and lots of other Star Trek movies is lightning in these nebulae, which we've never detected. It's kind of weird. They talk about the nebula being ionized or having electrons, that kind of thing, and you know, that is what you need to make lightning, but I'm a little skeptical of all these lightning-filled nebulae out there. So the picture I've got up here and the picture that I'm wearing are both of the Orion Nebula, an actual nebula in space in the constellation of Orion in his sword just under the belt. The picture I'm wearing is in the optical that we see with our eyes. This is an infrared image, so heat vision, basically. This was just released a couple weeks ago. From a telescope down in Chile, the very large telescope from the European Southern Observatory. And this is one of the deepest, most high-resolution images of the Orion Nebula. And what we have in this image are a few very big, bright stars, a hell of a lot of smaller stars, the sun and way smaller, planets around those stars most likely, and possibly a lot of free-floating planets that don't really have stars around them. So no lightning, no boulders crashing into each other, a bunch of stars and some planets.
So sticking with that nebula for a moment, the thing that I picked up on the most is they really do seem hell-bent on making nebulae seem way scarier than they really are. And the entire premise of the movie rests on this nebula being uncharted, really difficult to navigate. You need the most advanced starship around in order to navigate your way through this nebula. So how dense is a nebula? Well, to give you an idea of some densities in space, empty space is no such thing, really. Space is not a perfect vacuum. So empty space actually has about 1 atom in every cubic centimeter. A nebula has somewhat more than that because it's dense gas and dust that's condensing to form stars. This is a log plot, by the way, so 1 means 10 times higher. You wouldn't be able to see these if they were on a linear plot. So you think, okay, nebula is a lot denser than empty space, right? Well, it just so happens that certainly in the reboot verse, we've seen the Enterprise move through something an awful lot more dense than that nebula. Does anyone know what this is?
Seawater?
Air. We have actually indeed also seen the Enterprise move through water, which is even more dense than that. So if we're supposed to believe that the Enterprise can move and communicate through something that is many, many, many orders of magnitude more dense than a nebula, I'm really not scared of this nebula. I don't understand.
All right, on to the first attack from the baddies in this, these drone bee things. There is a lot of bad physics going on. So let's just break down a few of my favorites. You've got a lot of fire coming out of these explosions and crashes. There is flammable stuff inside the Enterprise. There's fuel, there's oxygen, which is flammable. But as soon as you get out into the emptiness of space, the vacuum of space, that's just going to quench. So you're not going to see these big fireballs coming out of it. You have stuff crashing straight through the hull and breaking apart, and a few people nearby might get sucked out into space, but other people a little further down just seem like they run down the hall. They're breathing fine, they're dying fine. That's not going to happen. This screen cap from the trailer at the bottom here, you see a lot of the baddies' ships kind of puncture the hull. They kind of open up, pop out, the guys run out and start shooting all the good guys on the Enterprise. This maneuver is called docking in space, and it is very hard and precise. You can't just ram into something. When we have spacecraft docking with the International Space Station, it's very precise, minute movements to catch up to the space station, get to the same speed, and then you have this very slow motion docking, clamping, regulating the atmosphere on both sides, and then you can enter. So just puncturing and popping in, probably not real. We don't have the sound going on this, but if you notice in this battle and the battle outside Yorktown towards the end, there's a lot of sound of exploding stuff. We know there's no sound in space, and so, yeah, lots of bad physics just in this first attack.
So you can't just smash into a spaceship, but Idris Elba can. So one thing actually that I didn't notice the first time we saw this movie and were frantically scribbling our science notes in the dark is that Sulu says something about after the impulse engines can't draw power anymore, they can't move. If you're in space, you're going to carry on moving. You don't need engines to keep going. So sticking with the laws of motion, who likes this scene of Scotty falling off the cliff? So this is a stunt you see in pretty much every action movie ever. You've got someone falling off a cliff, and somehow their horizontal momentum stops dead. And they're able to just fall down, sometimes even come back the other way and grab onto that cliff. And I think they do this on purpose, right? Because your subconscious understands the laws of physics pretty well. You see someone hurtling over the cliff, you know that they're going to their splattery demise. So when they're mysteriously able to grab onto the cliff, you get that surprise and relief. So I think they know the physics here is bad, but still, I'm going to tear it to pieces anyway. So here's our Scotty falling. So conservation of momentum is a pretty fundamental law of physics, like conservation of energy. In order to change your momentum, which is just your mass times your velocity, you have to have some external force acting on you. So as Scotty is being thrown over the edge of this cliff, he has momentum in this direction. So what forces are acting on him that could change the direction that he's moving? Well, the obvious one is gravity. That's going to move him downwards, but the horizontal and vertical are completely separate. Somehow we need to stop him moving sideways so that he doesn't go to his splattery demise. So something has to act this way. And that, as far as I'm concerned, is a total mystery. There's some air resistance that will slow him down, but to completely stop and reverse his motion, I have absolutely no clue.
Plot friction.
All right. So another big issue I have, a little bit similar to what I was talking about a minute ago. Twice in the movie, we have Bones and Spock in one of the baddie ships, and they pop open the hatch, the bad guys get sucked out, they close the hatch, they're fine. They barely hold on to anything, they're not gasping for breath because all the air was just sucked out. They even, at the very end, Kirk is flying out into space and they just hang out of the ship, grab him, pull him in, they're fine. They're huffing and puffing for a second and they're fine. So none of that makes any sense. Also, one thing that I really liked, if you watch a good sci-fi movie that has a lot of good physics, things like maybe Apollo 13 or The Martian, anytime they blow a hatch or something opens up in space, all the random little shits are falling out, right? There's, pens and batteries and things are flying out. Nothing flies out of these alien spacecraft. So they're either super OCD clean and everything is like really good in there, or it's all connected and bolted down. I don't know. But both times the Bones and Spock are in the baddie spaceships, it's just a load of horse shit. I'm sorry. I have to agree with Bones on that.
So one thing I've noticed about the science of Star Trek in general is that where you find the good science is not in anything that's actually relevant to the plot. It's in like the random little throwaway lines. And in this movie, we hear about the Magellan probe that was sent out to find a way through this big scary nebula. So obviously the Magellan probe in this movie is made up, but there is a real Magellan probe. It was actually the first planetary spacecraft launched from the space shuttle. So this is the launch. It was on the shuttle Atlantis on May the 4th, 1989, ironically Star Wars Day. So the Magellan probe, here's an image of it here, went out to Venus. It took the most high-resolution data ever of Venus's surface. And this animation here is actually made of data from the Magellan probe. One of the things it found is that Venus is covered in volcanoes, which is really cool. So I'm not really sure why they recycled the name, but it's kind of neat that they actually referred to something real here.
Okay, so here's another one. This picture in the bottom right is a little bit dark, but I will describe it to jog everybody's memory. But we have the saucer, just the saucer of the Enterprise now, crashing into the planet Altanid. Is that what it's called, I believe? I kept thinking Altoid when I saw it. Altanid. So it's crashing into the atmosphere of Altanid. You see, it seems that pieces are flying off of it. When we see it later on the ground, and that's sort of what this bottom right picture is showing, there's pieces that are on fire, it's kind of busted up, but it's still mostly intact, right? Chekhov and Kirk are running through it and doing a lot of stuff inside of it, so it's mostly okay. In the first reboot, we saw the Enterprise flying through a planetary atmosphere, no problem, so it can do that. But, it's pretty messed up, it's been through some badness, it's crashing through the atmosphere, so this actually is pretty legit. It would burn off sort of some of the outer layers, the leading edge as it's crashing through the atmospheric drag kind of burning off that front edge. So that sort of makes sense. The other thing, this is my second favorite scene in the movie, I'll get to my first favorite one in a few slides. My second favorite scene in the movie is also, I think, pretty good physics. It's when Chekhov and Kirk light the engines on the saucer of the spacecraft, of the Enterprise. And so, fuel rockets, once you light them on fire, they just burn out. Some you can kind of close and shut off, but most of them, you light it and they go. That was basically how the shuttle got up into orbit, and the Saturn V to the moon, etc. And so all they had to do was set that fuel on fire, and the thrusters just went, and they started creating thrust and force, and it was sort of dug into the ground. You have force coming out of the bottom, and it would flip over the saucer. That's totally reasonable physics. And then you see the flames out of the bottom, and it kind of just burns itself out. So that's totally legit. I thought it was a really badass looking scene when the saucer flips over and crushes the bad lady. And then that was cool. Now, MC High Z, Dr. Rachael here, chided me because nowhere in the Star Trek universe do they talk about any kind of chemical fuel. It's always antimatter, matter, or stuff like that. And that wouldn't do this. But if there's some chemical fuel, it would do that. That's pretty badass.
I think my biggest complaint is if they did have some kind of combustible fuel in the 23rd century somehow, why would they store it in the saucer? But anyway, on the subject of consistency with the Star Trek universe, cloaking. So this is a big departure from the original series. Nerds in the audience will know that in the original series, the Federation didn't get cloaking technology until 68-69, when Spock stole it from the Romulans. So they're going to get it early in this universe because Jayla managed to rig up some kind of light refraction thing to hide, this is the Enterprise, but she hid the Franklin that was down there on the planet. So this is pretty cool. Cloaking, like a lot of technology in Star Trek, is a thing that real scientists are working on. It's not quite as shiny as being able to hide a starship, but this is an experiment from last year at the University of Rochester. The idea is you hook up a series of lenses and you can bend light around an object. So if you're bending it from the other side around, it looks as though you're looking straight through the object, so it's effectively invisible. So this is a form of cloaking. Experiments like this come out every so often, and you'll see all these headlines in the papers about someone inventing Harry Potter's invisibility cloak. Another example of this is metamaterials. Metamaterial is just a material that's been engineered to have properties that don't exist in nature. It's just one of those made-up words. And this is doing the same kind of thing, right? It's managing to bend the light around the object so that you're effectively seeing straight through it. So this was a pretty neat little thing that maybe we'll get to one day. But as I said, I don't know about hiding starships, but then we haven't built a starship yet, so we've got a way to go.
All right, so Spock's kind of a creeper. at least with the jewelry thing, right? He gives Uhura a radioactive trackable necklace. And he says, it's made of Volkaya, it's from Vulcan, and it gives off low levels of radioactivity. The fact that it's an element that's only on Vulcan and not anywhere else in the universe is weird. As somebody who works on supernova that create all the elements that naturally occur, I should know if Volkaya was out there, and I've never seen it in a supernova, so a little skeptical. But okay, given that it's something on Vulcan, fine. This is actually pretty reasonable physics. On Earth, we have radioactive, naturally occurring radioactive material. There's uranium mines down in Australia and various places around the world. In fact, even bananas have potassium-40, which is a radioactive element. I'm going to take the peanut butter jelly time off there because that's just distracting. So, the fact that it's radioactive and radioactive materials decay, they give off energetic particles, that's what makes them dangerous, but they certainly are trackable. So the fact that the Franklin can track Uhura's necklace, it seems pretty legitimate if it is some kind of low-level radioactive material.
Still a really creepy game, though.
It's creepy. It's not great.
So, who likes this scene? I mean, I'm not going to get into why there's a motorbike on the starship, because, you can ask yourself these questions all night.
The director was from Fast and Furious,
Obviously. So, what you don't see actually in this clip, because it wasn't in the trailer where I could grab it, is when Kirk was transported from the Franklin onto the planet on his motorbike. Now, it's pretty well established in the Star Trek universe that when you go through a transporter beam, you maintain your momentum. So we saw this in the first reboot movie. Kirk and Sulu got beamed aboard the Enterprise as they were about to plunge to their deaths. If they lived in a universe with physics, they would have actually been splattered on the floor of the transporter room and had to be mopped up, and that would have been a very sad end to their day. Luckily, they live in a universe with no physics. So this gives us a problem with the bike scene, because how is Kirk transported onto this planet going full speed on his bike? So one possible explanation was suggested by our friend Todd from Odell Brewing when we saw this movie the first time, is that he was actually transported to a little bit before that, and then got up to speed, and then was transported again because of reasons. Which is better than
coming hot!
Right.
They can't be just starting from scratch.
Of course not. Thank you. That is much better than my explanation, which was that he started somewhere down the hallway, got up to speed in the transporter room, and got beamed down at exactly the right moment before he plunged into the wall. So this is one of those things that they did because it looks good in an action movie, I guess, but really makes absolutely no sense.
All right, so this is a point where we see that the entire crew of the Enterprise has failed basic physics. So Chekhov and Sulu sound really smart a lot of the time, except this point where they're talking about the terminal velocity, which Dr. Rachael will talk about in a second. What they really care about is the escape velocity. How fast do we got to get going to get out of the gravitational pull of this planet? And so to calculate that, that's pretty straightforward. You set the kinetic energy, the energy of motion, equal to the gravitational potential energy that's pulling you down onto the planet. This is one of the few times I will show equations in a public talk, but you do this calculation, and you get this escape velocity is the square root of 2 times g, gravitational constant from Newton, it's just a number, it's the same everywhere in the universe, times m, the mass of the object you're trying to escape, divided by r, the radius of the object you're trying to escape. You put in the Earth's mass and the Earth's radius, you get 11 kilometers a second, something like 26,000 miles per hour is the speed it takes to escape the Earth's gravitational pull. This planet looks pretty similar to Earth, so something like that. So this is a pretty damn fast speed, yet they don't say escape speed at any point in this ridiculous scene, so that's not great.
And honestly, if your ship is not designed to escape that kind of gravitational field, then you are not going anywhere. I may as well try to do that in my Nissan. So while we're on the subject of that dramatic takeoff towards the end of the movie there, you notice that they dived off a cliff and then had to reach their terminal velocity, which we'll get to, and then were able to swoop up in a very dramatic fashion just as they were about to crash. So this looks a lot like how a hang glider takes off. If you're on a hang glider and you're nuts, you jump off the edge of the cliff, and as you build up speed, you generate lift. So let's do a force diagram. They're always fun. What forces are acting on your hang glider? Well, there's your weight, which is the force of gravity of the planet acting on your mass. And then counteracting that, you hopefully, if you're not going to die, have lift. And the lift is generated by the wings of the hang glider. So one thing you notice about starships in the Star Trek universe, no wings. So it doesn't matter how fast you're going, you are not lifting off on a starship. Not by generating speed anyway. So let's get to that terminal velocity. Terminal velocity, the most common example used is with skydivers. I have never tried skydiving because jumping out of a perfectly serviceable aircraft doesn't seem like a sensible way to spend your time. But I've heard that once you reach your terminal velocity, this is where the air resistance is balancing your downward velocity. It feels as though you've stopped moving because you're no longer accelerating, you go in constant speed. So let's say you're in a starship jumping off the edge of a cliff. You again have your weight acting down. You have air resistance acting upwards, and at some point you will reach a speed where the air resistance is so high that you're not going to be able to accelerate anymore. It's the same as the force of gravity. So this is terminal velocity. For most objects on Earth, it's maybe a few hundred meters per second. So this is a real thing, but it does not mean what Chekhov seems to think it means. It doesn't help them in any way. First of all, as I already said, you're not going to be able to swoop and generate lift with your wings. So all you've actually done is made your problem worse, because instead of accelerating from 0 to 11 kilometers a second, you now have to accelerate from minus a few hundred meters a second up to 11 kilometers per second. So really, there was nothing redeemable in that scene whatsoever.
It looks pretty cool.
It is swoopy out of the trees. Yeah, I like it.
So they talk about they need to use very high frequency radio waves to somehow destroy the drone ships. Radio waves is a type of light. It's actually the lowest frequency type of light, and so that's not a good start. Sorry. They say, Scotty says very high frequency, and then Kirk's response is, yes, VHF, radio waves. Which VHF does stand for very high frequency. It is a type of radio wave, but that's actually pretty low frequency. So here is VHF. They then say they're going to broadcast at 57.7 megahertz, which is indeed part of VHF. That is where FM radio is broadcast, or TV over the airwaves is broadcast there. But even within radio, it's not the highest frequency. We've got UHF, ultra high frequency, also another great movie. This is where Wi-Fi, GPS, lots of other stuff, Bluetooth uses these frequencies. And then we have even higher frequencies in the radio waves. Things like this image of a disk around a young star forming new planets, taken from the ALMA telescope down in Chile. So astronomers use even higher frequency radio waves. So really, Kirk screwed the pooch on that one. Not good.
And from the fact that you can see an image constructed out of radio waves there, you know where I'm going next. So who here came to our contact screening? Yeah. So you remember this rant, right? Radio wave, as you've already said, is a type of light. It's a very low frequency type of light, so your eyes can't see it. But it is not sound. It so happens that we encode sound in radio waves and transmit it out to radios and TV or whatever, but it is not sound. So they do have frequency, so you can turn it into a sound if you want to, but AY and B 57.7 megahertz is not in the range you can hear. So what they're transmitting is not the sound itself, it's an FM radio signal. So unless all of these enemy ships have an FM radio tuned to 57.7 megahertz, also they said in the movie that there has to be a frequency they won't expect. Well, if they're not tuned to it, then it's not actually going to be anything whatsoever. Sure, this makes absolutely no sense whatsoever. It's really unclear why it blows ships up. That seems kind of dangerous to not be able to receive an FM radio signal without blowing pieces. But it gave them an excuse to do lots of explosions over Beastie Boys, I guess.
All right, so the last bit here. They at one point say that the radio waves won't travel far enough. And this is another recycled part of a slide from our talk at Contact, that radio waves, like any other light wave, just goes out into space until it hits something. So here is the radio and TV shows that we've been blasting out from Earth for the past 70 some odd years, and how far they've gotten and what stars they've gotten to. And so, that doesn't really make sense. Maybe if I give them the benefit of the doubt, they meant that it won't be loud enough or strong enough signal where they were. They had to get closer for that. And that makes some sense. These light bulbs are trying to show this, right? A light bulb right in front of your face is brighter than that same light bulb if it was held a mile away. And so light waves do get weaker as they get further away, and radio waves do the same thing. So maybe if I'm trying to be really generous, that made some sense. But the fact that they're using, this classical music, I'm a very big Beastie Boys fan. This was absolutely my favorite scene in the movie. Sabotage is a great song, a great video. I thought maybe they could have used instead intergalactic. It talks about space. There's the line Pinch on Neck from Mr. Spock, right, in that song. And nothing to do with Star Trek. License to Ill is one of my favorite albums of all time. I karaoke a bunch of the songs on that, so maybe over the highball later, we'll see. All right. So, Yorktown. This thing is awesome looking. I have some real physicsy astronomy type issues with this, but it is cool looking, so I will start with that. It gets light from a star, I think. Some of the shots have like this big bright spot off to the side, but not all of them. It looks like it's all at nighttime sometimes, so I don't know what's going on there. Even in this shot where you have the sun or some starlight, something on this side, this part of this ring and this ring is all lit up. This is sort of a dark side. The inside of that ring would be in nighttime. We see some scenes where it's rotating, so there's all kinds of weird shadows. It's not like, 12 hours of bright, 12 hours of dark. This sort of, some parts are in shadows, some parts aren't. There should be like city block-wide shadows changing on minute time scales. Those would be very wacky. The gravity in this, I don't understand at all. I mean, clearly they have magic gravity in spaceships that pull you to the ground fine. And clearly that's the case for every little spot, right? Like that's point down depends where you are. So, you go 2 blocks away to visit your friend, down is pointing in a different direction. So gravity is super wacky. I don't know what's going on. If you spun the rings, you could get gravity on the inside of the ring, but not the outside, and they don't seem to be moving. So I was racking my brain trying to explain this, and I really don't know about magic gravity. One cool thing, though, not really physics related, but movie related, was we had a few shots of buildings sort of at like 90-degree angles to each other. It reminded me of another awesome sci-fi movie I'm a big fan of, very Inception looking from what I was thinking when I watched this.
Yeah, and I think the reason the gravity works like that is shiny. That's the only excuse. By the way, I appreciate the Hamilton reference. That's cool. So in the climax of the movie, we have Kroll going to attack Yorktown, and obviously Yorktown being an artificial starbase because of reasons. I know they wanted to stay neutral on the planets, but there were plenty of uninhabited Earth-like planets that would save you the bother of building this huge structure in space and having to invent gravity and atmosphere and all this nonsense. But whatever, it's shiny. So we get to the big climax, and Kroll wants to release his badness across the whole starbase, and you do this, of course, through the vents. And their solution to stopping him doing this is shut down the atmospheric regulator. That seems like a really, really bad idea, because people kind of need that. As Scotty says, there's a lot of safety protocols on this thing that people need to live. Yes, Scotty, that's why you shouldn't be messing with it. However, I thought this scene was super shiny. So this bit where Kirk and Kroll are flying all over the place, I don't entirely understand why the gravity has suddenly gone fluey, but it is really, really cool. As Dr. Jeff said, it's very Inception-y, so I liked it a lot, and I don't really care that my physics brain had to be shut down for it. One little phrase that did make me go, huh? No, was gravitational slipstream. I don't know if anyone has an explanation for what that is, but this is what it made me think of. I can totally imagine Crush enjoying that a lot.
Alright, so we decided to each give a grade to this movie. So I will grade Star Trek Beyond 1 hovercat. Because it looks really cool, and it's entertaining. We just don't think about it too much, look at the physics behind it, just enjoy looking at it.
And very similarly, I am grading it 1 TARDIS. Because if you just think of it as pantomime in space and enjoy the fun times and try not to think about the wibbly wobbly timey-wimey physics, then it was pretty enjoyable. And I have to say, on this second viewing, I love Jayla so much. I really hope she stays in this franchise. So before we go, we wanted to say happy birthday to our friend Dr. Marshall Johnson. Marshall is also known as Captain Exoplanet. He's given a talk at Astronomy on Tap ATX. As well as it being his birthday today, he's just received his PhD a few weeks ago, and he's moving to Ohio on Friday. Happy birthday and all the best in your new job in Ohio, and I'm sure you'll miss us, so come back and visit.
All right, and then quick ad for the next Astronomy on Tap ATX event. On August 16th over at the North Door, just east of 35 and 5th Street. We're going to have Professor Caitlin Casey talking about the most extreme galaxies in the universe. I am plugging this because I will be speaking at AoTATX, talking about my work on exploding stars in the runaway universe. And then we're going to have Chris Johnson from, what is the radio station? It's not in there. The local classical station, KMFA?
Yeah.
All right, KMFA. Talking about the influence of astronomy on classical music, which we now know includes the Beasties. So if he doesn't talk about Hello Nasty album in there, I'm going to be pissed.
All right, and we just want to say a huge thank you to the Alamo Drafthouse for hosting us tonight. To Odell Brewing Company, the official beer of AoTATX. To Captain Exoplanet for doing our filming tonight. The portion of this will be up on YouTube for those of us who couldn't make it tonight. And of course, you, the audience, for coming out and sharing this movie with us. Thank you very much for coming.
Thank you.
And the Alamo were only able to give us this theatre for an extra 30 minutes, so we can't take Q&A here, but we will be hanging out in the highball. So if you want to ask us questions, if you want to rant about the physics yourself, if you just want to talk Star Trek, come hang out in the highball. So thank you very much.